Okay, in this video I'm going to show you how to download and manipulate some data, make a data table in Excel, and add that into a map and then display it by latitude, longitude. We'll get our data from U.S. Geological Survey, and we're going to look for worldwide earthquake data. There are a lot of sites having to do with the Geological Survey and the and earthquakes. It's a little hard to figure out where to go. You can just blunder around until you find it. I happen to know that this one is the easiest way to find what we're looking for. And over here, there are different ways to get to this, but the easiest way is to search the earthquake catalog. So what we'll do, we'll just choose magnitude greater than 6, fairly large earthquakes. Let's do a long time. Let's go 1950, January 1st at 0 hours, 0 minutes, 0 seconds. Okay, and we want the entire world. Advanced options, you can pick a bunch of different possibilities of limited areas and so forth. We won't mess with that yet. There's several formats. KML is the keyhole markup language that's used by Google Earth. What we want though is CSV. That's comma separated values, comma delimited text, which Excel can open and manipulate nicely. We need to type in a maximum number. They'll only let you download 20,000 events at a time. So let's now search. All right. And okay, I'm going to just go ahead and save this, and then we'll edit it some. Need to keep track of where it is. And I'm going to call it, I've already created a file with that name, Earthquakes 02. And yes, we'll replace it. Must have another one open. Let's just call it Earthquakes 03, just to keep it moving here. All right, it's asking, do I want to save this format, because I can't do equations and I can't do graphics, but that is what we want. Now, right now we don't need a lot of these columns, so I'm going to delete a bunch of columns. Depth would be interesting if we were doing 3D. Magnitude would certainly be interesting, and there's a lot of other interesting data if you're more expert than I. But I just want to save latitude and longitude. Let's see how many. So we've got about 9,600 lines of data. That should be fine. Let's save, and we want to save it as CSV. Now let's close Excel. We don't want to save. It wants to save it as an XLS file. That isn't what we want right now. Okay. There's the one that was open that shouldn't have been. Okay, here we are in ArcMap. Let's go ahead and close our browser for the moment. Let's put some data in here. Let's get a world map, and let's just put world countries. We didn't set it, but let's check data frame properties. It's the web Mercator. This is a real common web-based coordinate system. So now what we want to do, this is the point of the video, is to add some data. Let's go up here to my data file, and here's what we just downloaded as a CSV file, and we add that. And there's nothing there actually, because all this is a data table now. So what we want to do, we right click on it and we go down here to display XY data. So the X field is longitude, the Y field is latitude. We didn't include depth or any other Z field. And we don't want the web Mercator. This is WGS84. This is a geographic coordinate system. So we need to choose not a projected, but a geographic. And we go down to world, and it'll be down here, WGS84. Whoops, that looks like I've got a, let's close the projected. Let's reduce the confusion and just search for WGS, and that makes it easier. Less junk shows up. Okay, that should work okay, and okay. This is a warning. I can't manipulate this as a shapefile. We'll have to write it out as a shapefile. So there we are. And so I'm going to write this out as a shapefile because it's it writes out this thing called earthquakes03.csv events. And what I want to do is go to data, export data, and yeah, let's keep it in worlds. We're going to make a that's a good place to put it. We don't want to call it export output, but we can say earthquakes. Let's give it the same number so we'll know where the data came from. And let's add it. Okay, we can actually remove it if we want. For the moment, I'll just turn it off. Let's symbolize it a little bit more nicely. Let's see, let's make it something small across. Let's make them red, I guess. And not 18, but something like 4 points, something fairly small probably. Alrighty. Now, this is not a very good, the web Mercator's not a very good projection. Let's change now for the whole data frame. Let's do a projected coordinate system, and let's go to world. And this is one, the ITOF. It's not all that commonly used, but I kind of like it. So, and what I'm going to do is, while we're here, I'm going to change the central meridian from 0, which is the observatory in Greenwich, England, to -100. Whoops, not 1,000, but 100. And that'll center our map somewhere around the middle of Kansas. So let's make that full. And you can see now, you can see the outline of Africa out to, this is actually the mid-Atlantic ridge. You've got your Pacific plate, you got your Nazca plate, you got your Philippine plate, the African plate, the South American, the North American. The tectonic plates, of which the Earth's surface is constructed, show up in outline when you plot all these earthquakes. Anyway, that is all we'll do for this particular video.